Tom Pittman studied information management at Brigham Young University and computer information systems at the University of Alaska. He has worked as an IT executive both in the public and private sector, leading teams that have won local and national awards for innovation and excellence. A former CIO, CTO, and CEO, Tom is currently the founder and CEO of a new Orem-based startup called Xample Inc., which currently is in stealth mode as it finishes the first iteration of its core products. Tom is also a Native American, born and raised in Alaska, and is married to a British girl who was born and raised in England. Between the two of them, they like to tease that the 4th of July is not their favorite holiday. The Pittmans moved to Orem, Utah when their older children began to reach their college years. In fact, of their 7 children, 3 have graduated from BYU, and the other 4 are either UVU graduates or current UVU students. The topic of Tom's presentation is Functional Killed the OOP Star. Our agenda is simple. After a brief introduction, we are going to talk about what programming is for the non-programmers in the room. We're going to go over the history of programming so we can understand why object-oriented programming is so popular today. Then we will talk about why functional programming is trending so strongly right now and why you need to know about it. The great philosopher, Jeff Foxworthy, is well known for his redneck jokes. For those of you who are born in England like my wife and don't really know what a redneck is a rural American known for having an overly simple lifestyle. For example, according to Professor Foxworthy, if your wife has ever said, "Come in here and move this transmission so I can take a bath," you might be a redneck. Or if your kids have ever taken a siphon hose to school for show and tell, you might be a redneck. By the way, if this is the redneck who wants to siphon your gas, I suggest you let her. You might be a redneck if, when asked for your identification, you show them your belt buckle. See, right here it says TOM. Now, ma'am, that don't make no sense at all. Why would I go and wear some other feller's belt buckle? This is where I grew up in Alaska, Sitka. Having been born and raised in Alaska, I have to admit that I really haven't had a lot of experience with rednecks. However, as a lifelong technology executive, I do have a ton of experience with stiffnecks. Unfortunately, there are a lot of them in our industry. The dictionary defines stiff-necked as haughty and stubborn. By the way, for the record, haughty is spelled H-A-U-G-H-T-Y, not H-O-T-T-I-E. There is a difference. In this spelling, haughty is not a good thing. It means arrogantly superior and disdainful. To help us keep these two words straight, I've made the following chart. The British woman on the left, not good. The British woman on the right, very good. She's my wife. This message has been brought to you by Xample Inc. Like our tagline says, better information, better decisions. Whether it's Apple versus Android, Windows versus Mac versus Chromebook, Microsoft versus open source, privacy versus security, you name it. And there are people who can get downright religious, territorial, and arrogantly superior and disdainful about their technology preferences. Mind you, I'm not talking about honest differences of opinion. Those are good. Well, not always, but they can be good. I'm talking about people with minds like concrete, all mixed up and permanently set. Consequently, it is a good idea to step back once in a while and evaluate your own technology biases. After all, it's just technology, not religion. I do have to say, though, that it is super easy for any of us to become tech stiffnecks, including me. When something works well for us, we tend to grow fond of it. We can even start to think, my eyeglasses work great for me, therefore everyone should wear my prescription. That's just not how the world works, and we need to be mature enough to acknowledge that. One antidote to tech stiffneck is to remember that technology is never the goal. Technology is just a means to an end. Whenever I feel myself being drawn into a debate about which technology is better, I just remind myself that no one goes to Lowe's because they want a drill. They go to Lowe's because they want a hole. The drill is just a means to an end. Consequently, if someone were to invent a faster, better, cheaper way to make holes, I hope I wouldn't be so in love with my pet drill that I wouldn't seriously consider that there could be a better way. After all, I'd hate to have my grandchildren look up stiff-necked in the dictionary someday and see a picture of me. And my belt buckle. Speaking of grandchildren, I'm probably the only person in the room with 6.7 grandchildren. As someone who has recently qualified for the senior menu at IHOP, I have to say that I'm disappointed at how many young people are stiff-necks. You're not going to believe this, but some people let themselves become really opinionated while still in college. I knew you wouldn't believe it. You never really learn anything when you know it all too soon. I have a friend who recently graduated from BYU with a master's degree in information systems. He's a super bright kid. But when I asked him what BYU is teaching about functional programming these days, he was confused. After asking me to repeat the question, he said, "Shouldn't all programs function?" Of course, it's not his fault if his school doesn't teach anything about functional programming. That doesn't make him a stiff neck. But if he were to continue throughout his career without bothering to learn anything about FP, that would definitely put him on the road to being a stiff neck. I have another friend who is a UVU graduate. He manages a team of programmers for a very large and influential Utah-based business. You will be happy to know that when I asked him his opinion of functional programming, he knew what it was. Go Wolverines. However, to my dismay, he scoffed and said, "Functional programming? Why would I bother with functional programming? Didn't object-oriented programming win that war long ago?" By the way, for future reference, we Native Americans don't really like to talk about who won what wars long ago. Besides, times change. Just ask the BYU and UVU men's basketball programs. But before we get into how times are changing, let's talk about what programming is. Say we're at a UVU men's basketball game. Coach Mark Pope calls timeout. The Green Man group runs out onto the floor and begins drumming, and Willie the Wolverine runs out to the center of the floor and holds up a sign and encourages us all to yell the words on the sign together. You ready? Are you in? Me neither. For some reason, even non-English speakers prefer Go UVU over binary code. Strictly speaking, computers operate in terms of on and off. That's it. To help us humans communicate with computers, we have designated the numeral 1 to represent on and 0 to represent off. This is called abstraction. Abstraction organizes computer instructions in ways that make them easier for humans to understand. That said, ones and zeros aren't exactly easy for humans either. While low-level abstractions like the ones and zeros of binary code or machine language are faster and easier for computers to execute, low-level abstractions are very hard for humans to understand. To make things easier for humans, over time, we've began adding layers of abstraction to make communicating with computers more viable. However, the more we abstract away from the hardware, the more we tax the resources of the computer. So what is programming? Programming is abstraction. Programming takes the logic humans can understand and expresses it in terms a machine can understand. For many computers back in the day, that meant machine language. For most computers of our day, it means using a higher level programming language. Now that we've discussed what programming is, let's talk about why object-oriented programming is popular today. As you know, in the beginning, people used binary coding to program computers. These methods were painstakingly slow and terribly expensive, but at least they were really buggy and took forever to get working. Before long, some people began using assembly language instead of binary code. At the time, this was controversial, and people were critical of them for using it. But then again, there's no sense in owning a computer if its software is never ready. Soon the world would move up from assembly language and begin to embrace general-purpose programming languages. These languages abstracted from the hardware even further than assembly language, but they were closer in the logic that humans could express, so software actually got finished. The first two general-purpose programming languages that are still in existence are Fortran, born in 1957, and Lisp, born in 1958. The interesting thing about how these two languages abstracted is that Fortran was an imperative language, and Lisp is a functional language. The object-oriented languages of today, like Java, PHP, and C# are imperative languages. They are the descendants of Fortran's family tree. And the functional languages of today, like F#, Elm, and Elixir, are in Lisp's family. To help us all understand the differences between these two abstractions, here's a very simple look at how imperative languages and functional languages express the same statements. Assuming that x equals 1, y equals 2, and z equals 3, can you find the solution for A? The solution is 3. If that makes sense to you, then congratulations. You officially understand functional programming. Here's the imperative expression of that same statement. As you can see, functional is not harder at all. It is just expressed differently. Let's try another one. Notice the differences in punctuation between the two expressions? Instead of parentheses, the second problem uses square brackets, and instead of commas, it uses semicolons. That means that the second expression is looking for an answer that is a list or a collection, instead of a one-integer solution like the first problem. So what is the solution for C? 149. I hope you can see that functional expressions are not harder. In fact, if you have used Microsoft Excel much, you might find functional expressions easier than imperative. Just look at how close the Excel expression is to the functional. Excel is probably the world's most popular unofficial functional language. Perhaps you've noticed that I haven't shown you the imperative equivalent of that second problem yet. That's because writing it out wouldn't exactly fit in this space. Here's the imperative code to that problem. It is expressed in an object-oriented language called C#. In black and white is the solution to that same problem coded in F#, a hybrid functional/object-oriented programming language. This part of the C# code corresponds to the first line of the F# code. And this part of the C# code corresponds to the second line. Please notice the difference in incidental complexity, things like curly braces, semicolons, for loops, etc. Incidental complexity is the complexity forced on your code by the language. It's what the language requires to do its job. The logic doesn't need this stuff, the language does, and functional programming languages have far less incidental complexity. Michael Feathers wrote, "Object-oriented programming makes code understandable by encapsulating moving parts. Functional programming makes code understandable by eliminating moving parts." I like that. The problem with functional languages in the 1960s is that the functional abstractions used immutable data which require slightly more memory to process, which back then was a big deal. As you may know, you can buy an 8 GB flash drive online for $4.74. For perspective, check out NASA's IBM 7090 mainframe pictured here. As impressive as this looks, it had just 8K of memory. That is substantially less memory than many of our modern doorbells today. Mainframe computers used to have between 8K and 64K of memory. Adjusting for inflation, the 64K mainframe would cost about $107.5 million today. Can you imagine buying a computer with just 64K of memory and paying $107.5 million for it? Given those costs, you can see why people were so concerned about every bit of memory usage. And yes, the pun was intended. Here's another way to look at it. This is core memory. In the 1960s, core memory could not be made by machine. It had to be hand-woven. Prominent computer scientist Robert C. Uncle Bob Martin says that in the 1960s, he used to buy core memory like this on 5 12-byte racks for $512 from Army surplus. At those prices, Robert Martin says 8 gigabytes of memory would have cost $64 billion back then. I hope you're getting the picture. Functional programming requires slightly more memory than procedural. Given the cost of memory back then, is it any wonder that the industry went the more affordable route? This is why most of us are object-oriented programmers today. It never was really a matter of computer science, it was a matter of economics. Thankfully, hardware has been getting cheaper and better over time. Well, unless we're talking about Apple's 2016 MacBook Pro. Too soon? So now we move on to part 3, why functional programming is trending now. All over the world, people are waking up to how remarkably well suited functional programming is for building today's real-world production applications. In fact, I think it's possible that history could look back at 2017 as a seminal year in the renaissance of functional computing. Simon Bisson has written, "The sands of the IT world are shifting as the cloud and mobile move from being secondary to the old N-tier plus web model that's dominated for so much of the last decade. That sea of change is shifting the languages that we use today, away from the C family of languages such as C++, C#, and Java, to one that descends from more formal languages such as Lisp." Let's talk briefly about 3 Turing Award winners. In 1971, John McCarthy won an ACM Turing Award. His notable achievements include being the inventor of Lisp, a functional language, and inventing utility or cloud computing. It just blows my mind that he invented both of those. It's as if functional programming and cloud computing were always meant to go together. In 1977, John Backus won an ACM Turing Award. When you get a Turing Award, you get to publish a paper, and Dr. Backus used his Turing Award paper as an opportunity to try to convince the world that now that hardware was more affordable, functional programming is actually the better route than the one he invented. Dr. Backus titled his paper, "Can Programming be Liberated from the von Neumann Style? A Functional Style and Its Algebra Programs." About the time that Drs. Backus and McCarthy were getting their Turing Awards, there was this jazz musician with a PhD from the University of Utah that began to innovate in astonishing ways. His name was Alan Kay, and he was part of the team that invented the graphical user interface, the mouse, the laptop computer, touchscreen tablets, ebooks, Smalltalk, and he coined the term object-oriented programming. I hope you recognize how astonishingly significant Dr. Kay's work is. He basically laid the foundation of modern computing. Alan Kay's Turing Award paper was titled, "The Computer Revolution Hasn't Happened Yet." Alan Kay thinks the best innovations are being ignored by industry. While not part of his Turing paper, Dr. Kay is critical of today's so-called object-oriented languages, saying, "None of them are object-oriented systems according to my definition. Objects were a radical idea, then they got retrograded." Retrograded? In what way? Well, Smalltalk had higher order functions and lambdas, features that today are considered key parts of functional languages. In other words, originally object-oriented programming was meant to be much more functional than the so-called object-oriented programming languages are today. Let's pause for a minute and consider what we've just covered. These guys are not just some dudes with opinions. The actual founding fathers of functional programming, imperative programming, and object-oriented programming are all trying to tell our stiff-necked industry that what we are doing is not the best way forward. We need to get more functional. It is sad how slow the tech industry can be to embrace change. Even after hardware got better, the stiff-neckedness of our industry kept functional programming on the bench and never really allowed it to get in the game, except in Europe. In 1986, Joe Armstrong, Mike Williams, and Robert Verding designed a functional language to control their employer's telephony. They named the language Erlang. This language did things no other programming language could touch. Its native symmetric multiprocessing, lightweight operation, speed, and reliability had never been seen before in their industry. Throughout the 1990s, Ericsson leveraged Erlang to build out its network and gain a competitive advantage. Then 16 years later, Ericsson banned the in-house language Erlang and began to move to a non-proprietary language. As a result, in 1998, Ericsson made Erlang open source, and Ericsson's tech employees fled Ericsson to their competitors, such as Nortel and T-Mobile. Using the newly open-sourced Erlang, Ericsson's competitors made their networks impressively performant and reliable. Before long, Ericsson's former functional language, Erlang, controlled 40% of the world's data communication. By the way, Ericsson eventually reversed its policy on Erlang, and some of their key employees returned, but by then their secret sauce was no longer secret. Erlang was in the wild for everybody to use. Here's the photo of the guy who decided to dump Erlang for the non-proprietary OOP. Yeah, I'm kidding. In July 2016, Charles Scalfini wrote an excellent essay titled Goodbye Object-Oriented Programming. In it, he wrote, "It has taken me years to realize how OO lied to me. I was too wide-eyed and inexperienced and trusting, and I got burned. Goodbye, object-oriented programming. Hello, functional programming. It has been so nice to work with you over these past few years." About the same time that Erlang was proving itself in Europe, Intel discovered that certain Pentium chips were defective. Under normal use, these defective processors would produce an incorrect calculation about once every 24 days. I was about your age at the time, and I remember telling jokes like, "How many Intel engineers does it take to change a light bulb? 3. 1 to change the light bulb, and 1 to test it." Ba-doom-tsh. In response to the Pentium bug, Andy Grove did 3 things, and I really admire him for all 3. First, in December 1994, Intel announced a massive recall of its Pentium chips. The recall cost Intel about $475 million, which was an enormous hit for any company to absorb, including Intel. In fact, some people wondered out loud if this would take Intel under. Second, Andy Grove ordered some of the defective Pentium chips be made into keychains. On the back of the keychain it said, "Bad companies are destroyed by crises. Good companies survive them. Great companies are improved by them." The third thing Intel did had to do with that last line on the keychain. Great companies are improved by crises. Do you know how Intel improved itself? Intel created a proprietary functional language for use only inside Intel to program their chips. And ever since Intel went functional, they have never had a processor bug again. So in the 1990s, functional programming enjoyed impressive successes in the real world. The interesting thing is how quiet these companies were about their successes. Why? Well, because they considered functional programming to be a competitive advantage. For example, Paul Graham has a PhD in computer science from Harvard, but he is best known as the co-founder of Y Combinator. Dr. Graham attributes the success of his 1995 startup, ViaWeb, directly to their decision to build their product in a functional language, while their competitors used object-oriented programming. In retrospect, Dr. Graham wrote this on his blog. But with Lisp, our development cycle was so fast that we could sometimes duplicate a new feature within a day or two of a competitor announcing it in a press release. By the time journalists covering the press release got around to calling us, we would have the feature too. It must have seemed to our competitors that we had some kind of secret weapon, that we were decoding their Enigma traffic or something. In fact, we did have a secret weapon, but it was simpler than they realized. No one was leaking news of their features to us. We were just able to develop software faster than anyone thought possible. In 2002, Intel betrayed object-oriented programmers. It released the first modern desktop processor to implement simultaneous multithreading. Prior to this moment, the ever-increasing complexity of software could count on the ever-increasing clock speeds of processors to keep that software performant. Not anymore. Thanks to a shift in processor design, if the software industry was going to continue to take advantage of processor improvements, it was going to have to change the way it built software. Shift happens, of course, but this shift changed the game. On this topic, Michael Swain of Dr. Dobbs wrote, "Chipmakers have essentially said that the job of enforcing Moore's law is now a software problem. They will concentrate on putting more and more cores on a die, and it's up to you to recraft your software to take advantage of the parallel processing capabilities of their chips." I'm sorry to say, though, that despite this obvious shift to multi-core processors in 2002, a frighteningly large portion of the software industry continues to party like it's 1999. While you don't have to go functional to go parallel, it certainly is easier. As the great philosopher Anonymous once said, "It's not what a programming language can do that matters. It's what a programming language can make easy." There are 7 real-world reasons to give functional programming a chance. Better software quality, better concurrency, improved developer velocity, lower software development costs, improved scaling, better team and project management, and higher programmer happiness. I wanted to dive deeper into each of these 7 points in this talk, but I just don't have time. However, for those who would like to learn more, I've posted an essay discussing them on the homepage of Xample.com. I figure that since Xample is in stealth mode anyway, I may as well make it look like a blog. Up until now, I have been all stories and anecdotes, so some of you have probably been wondering, do you have any actual research to back your claims? My answer is, of course I do. I'll tell you about 2 of them, but there are more. But before we do that, do you remember this slide? My youngest daughter, Emily, saw me create it and said, "Dad, don't use a picture of Mom, use a picture of me. You're giving this to college students, not to old guys like you." Well, I figure if my daughter wants me to embarrass her in front of all you, then I shouldn't disappoint her. And because I'm the kind of guy who likes to go the second mile. Contestant number 7 is Emily Pittman. Emily is a 19-year-old psychology student at Utah Valley University. Emily enjoys singing, performing, and hiking with her bloodhound, Annie. Emily hopes to one day marry someone just like her dad. So, if you are a computer science, computer engineering, digital media, information systems, information technology, or software engineering major, feel free to follow her on Instagram. Contestant number 7, Emily Pittman. Yeah, I'm in trouble. If I'm not in trouble with my daughter for that slide, then I'm in trouble with my wife for that hottie slide, right? But I'd probably be in more trouble if I use some other hottie on that slide, so maybe it'll work out. In the very same year the Pentium bug was discovered, 1994, Yale professor Paul Hudak got an ARPA grant to study programming languages. To test the efficacy of different languages, researchers gave a programming project to 9 independent teams of programmers to code a solution, each team using a different programming language. By the way, all the languages were object-oriented except for one, a pure functional programming language called Haskell. Each team's product was measured by 4 metrics: lines of code, development hours, lines of documentation, and the quality of the prototype. I'm sure you've guessed by now that Haskell, the functional language, won. But it's what happened after it won that makes the story so cool. The functional programming language outscored the object-oriented programming languages by such a ridiculous margin that researchers concluded it must have been an outlier. The FP probably just had an extraordinarily brilliant team. So, to make it more fair for the object-oriented programming languages, they grabbed a graduate student and gave him 7 days to learn Haskell, then made him code a solution to the problem. Sure enough, the graduate student's Haskell solution wasn't as good as the first Haskell solution, but it was good enough to come in second place and score far ahead of the object-oriented languages. In 2014, the University of California, Davis published a study that sought to answer this question: what is the effect of programming languages on software quality? Isn't that a great question? Haven't you wondered that as well? Are some programming languages more error-prone, while other languages actually help you write higher quality software? I don't know what your opinion is on the impact of a language on software quality, but there was a time in my life when I would have answered this question saying, the language doesn't really matter. If the programmers are proficient at whatever language is being used and the project is being managed and tested well, the quality of the software will be good, regardless of the language. However, like everyone else, my position was just based on my experience. I had no data to support it. In an attempt to find a credible answer to this question, an answer that an entire industry could trust, these researchers studied an enormous dataset, 729 software projects from GitHub, with 80 million lines of code, written by 29,000 different developers, with 1.5 million commits and 566,000 bug fix commits. Moreover, the code they studied was not from obscure, unsuccessful projects that had no bearing on software being used in the real world. They analyzed the source code of projects such as Linux, Node WebKit, Mongo, Docker, jQuery, Node.js, Rails, Django, CodeIgniter, Bootstrap, Bitcoin, etc. They considered 17 programming languages, including C#, Objective-C, Go, Java, CoffeeScript, JavaScript, TypeScript, Ruby, PHP, Python, Scala, Clojure, Erlang, and Haskell. So, what did they learn? First, they found that the quality of software is, quote, overwhelmingly dominated by process factors, such as project size, team size, and commit size, unquote. In other words, software quality is largely affected by how the project is managed. That should make sense to us all. Second, they also concluded, quote, the data indicates functional languages are better than procedural languages. It suggests that strong typing is better than weak typing, that static typing is better than dynamic, and that managed memory usage is better than unmanaged, unquote. So, on the question, what is the effect of programming languages on software quality? The answer is, the data indicates functional languages are better. Of course, just because some study says so, doesn't necessarily mean it's true, right? After all, they told us for decades that margarine was better than butter, and that didn't turn out to be true. Sadly, I sacrificed many a batch of popcorn on the altar of bad science. However, if you are tempted to dismiss these findings in favor of your own opinion, please ask yourself, am I being a stiff-neck? An unbiased scientific study analyzing a massive dataset of 80 million lines of code written in 17 different languages by 29,000 different programmers ridiculously exceeds the lifetime experience of any programmer, including you. especially when you consider that many of these 729 projects contain code that the world depends on every day. I'd like to pause here and remind everyone that I'm not a professor or an academic. I'm a business owner. I haven't researched this stuff because I thought I'd one day get to present it to someone. I researched this because at Zampo we have a once-in-a-generation transformational product, and I want to give us our best chance for success. This research led me to the conclusion that functional programming is the right technology stack for us to build on. In other words, this isn't a theoretical, academic, or hypothetical argument to me. We're putting our own money on this, and I would not do it if I thought it would go to waste. Now please don't misunderstand. I really do like object-oriented programming languages. There are plenty of circumstances where I would consider Swift, C#, Java, Ruby, or TypeScript for a project. In our particular circumstance, where we have no legacy code burden, for us, functional programming is ideal for our green field. The three functional languages I recommend you check out are F#, Elm, and Elixir. Let's talk first about F#. When Jet.com was founded in January 2014, they started building their project in an OOP called C#. Then after some interesting tests, which I don't have time to go into, they began using a functional language called F# instead. Now because F# programmers were hard to find, they hired C# programmers who claimed that they were open to learning functional programming. On August 8, 2016, Walmart announced it would buy Jet.com for $3.3 billion. Walmart is dumping its entire online shopping system and replacing it with Jet.com's functional F# technology. How amazing is it that a profitable company would drop a perfectly good online shopping system and spend $3.3 billion to get something else? They must think the new system has quite a competitive advantage. By the way, Jet.com has plenty of other innovations. This isn't just about their F# technology stack. But Walmart's purchase of Jet.com made me feel pretty good because we're using F# to build our products as well. This felt like a big validation to our technology stack. On February 24, 2016, Microsoft bought Xamarin, a development environment that allows developers to build native apps for iOS, Android, and macOS using C# and F#. This means that F# is the only functional language in the world that can build cross-platform mobile apps, desktop apps, back-end services, and of course big-time web apps like Jet.com. By the way, F# is a hybrid programming language, supporting both functional and object-oriented abstractions. The next language I recommend you look into is Elm. Elm compiles to HTML, CSS, and JavaScript, the three most nonsensical languages in wide use today. If I were a front-end programmer, I would definitely want to replace that crazy mess with one beautifully designed pure functional language. In addition to F# and Elm, I recommend checking out Elixir. Elixir is a Ruby-like functional language that runs on Erlang's virtual machine. In other words, Elixir is a better way to code than Erlang, yet it runs on Erlang's infrastructure and has Erlang's performance benefits. Now, I know that there are a lot of other functional languages out there that people adore and are quite passionate about, but in terms of practicality in the real world, these are the three I recommend: F#, Elm, and Elixir. By the way, our first product is targeted at your demographic, and we could use some beta testers. If any of you are interested, please email me with the subject Zampo Beta. When we're ready for you, we'll be in touch. Okay, one last story, then a 3-minute video clip, then we'll pause to answer questions. In 2007, Brian Acton and Jeff Kalm left Yahoo and traveled to South America for a break from work. When they got back to the United States, they applied for jobs at Facebook, and both were rejected. They took their savings and decided to build a mobile app. They found a Russian developer on rentacoder.com named Igor Solomenikov and got to work. 7 years later, in February of 2014, Facebook bought their app for $19.3 billion. At the time, WhatsApp was the most popular messaging app in the world. It had 700 million active users sending over 30 billion messages every day. Also at that time, WhatsApp was sharing 700 million photos a day and 100 million videos. Perhaps even more remarkable was the fact that WhatsApp was doing this with just 32 engineers. How did they do it? They decided to build WhatsApp using a functional programming language that was open sourced in 1998 by a Swedish telecom company called Ericsson. Yep, WhatsApp chose Erlang because it is a massively scalable system with built-in support for concurrency, distribution, and fault tolerance, making it highly available, highly performant, and highly scalable. And Erlang continues to scale well for Facebook. Today, WhatsApp is still the most popular messaging app in the world, with over 1 billion active users. And now WhatsApp does international voice calls, processing 100 million phone calls a day. And the latest data that I could find on how many engineers WhatsApp currently has is 50. And according to Facebook, they're beginning to use Erlang at other places in their company as well. Now obviously, object-oriented programming is still the predominant way that software is being built today. What I'm talking about is a movement that is going on concurrently with the rise of cloud computing, a movement I'm hoping all of you will consider.
So ladies and gentlemen, at TED we talk a lot about leadership and how to make a movement. So let's watch a movement happen, start to finish, in under 3 minutes and dissect some lessons from it. First, of course you know, a leader needs the guts to stand out and be ridiculed. But what he's doing is so easy to follow. So here's his first follower with a crucial role. He's going to show everyone else how to follow. Now notice that the leader embraces him as an equal. So now it's not about the leader anymore, it's about them, plural. Now there he is calling to his friends. Now if you notice that the first follower is actually an underestimated form of leadership in itself. It takes guts to stand out like that. The first follower is what transforms a lone nut into a leader. And here comes a second follower. Now it's not a lone nut, it's not two nuts, 3 is a crowd, and a crowd is news. So a movement must be public. It's important to show not just the leader, but the followers, because you find that new followers emulate the followers, not the leader. Now here come 2 more people, and immediately after, 3 more people. Now we've got momentum. This is the tipping point. Now we've got a movement. So, notice that as more people join in, it's less risky. So those that were sitting on the fence before now have no reason not to. They won't stand out, they won't be ridiculed, but they will be part of the in crowd if they hurry. So, over the next minute, you'll see all of the those that prefer to stick with the crowd, because eventually they would be ridiculed for not joining in. And that's how you make a movement. But let's recap some lessons from this. So first, if you are the type, like the shirtless dancing guy, that is standing alone, remember the importance of nurturing your first few followers as equals. So it's clearly about the movement, not you. Okay, but we might have missed the real lesson here. The biggest lesson, if you noticed, did you catch it? Is that leadership is over-glorified. That yes, it was the shirtless guy was first, and he'll get all the credit, but it was really the first follower that transformed the lone nut into a leader. So as we're told that we should all be leaders, that would be really ineffective. If you really care about starting a movement, have the courage to follow and show others how to follow. And when you find a lone nut doing something great, have the guts to be the first one to stand up and join in. And what a perfect place to do that at TED. Thanks.
If you have ever been fired from a construction job because of your appearance, you might be a redneck. If most of your wardrobe has logos on it, you might be a redneck. If you have ever climbed a water tower with a bucket of paint to defend your sister's honor, you might be a redneck. And if you've listened to all this evidence and are still not the least bit curious to check out functional languages, I'm sorry, my friend, but you might be a stiffneck. On the other hand, if you think that the lone nuts that we talked about today, who have been pioneering functional programming, are doing something great, then why not become one of their first followers and help us start a movement? We'd be glad to have you. Cheers.